Every time the reflection of light follows these set of rules, because of which we can identify certain component with respect to the reflection. Sine of angle of incidence is divided by sine of angle of refraction, that is known as Snell's law, which is also called as the refractivity. Hello everyone, I'm Brinda, Faculty of Physics, welcoming you all to Chapter 9, Session 1 of the chapter named Ray Optics and Optical Instruments. In today's class, let us study something more about optics with respect to reflection as well as refraction. So first of all, reflection of light. So how exactly the light reflects? You can see with respect to this, the light reflects this image on the water reservoir. Likewise, there is a mirror which is actually useful in case of reflection, which we use in our daily lives. So for all the reflections to undergo, there is certain set of rules which has to be followed. With respect to the rules, if you go, there are out of these, that is the set of reflection rules, there are two rules with us. So one rule is that this is the incident ray which is coming towards the surface. This is a surface on which the ray is getting reflected. So the incident ray, the normal means this is the one which is equal to 90 degree normal, as well as the reflected ray. All three rays lie on the point of incidence is on the surface of the material. Okay, the point of intersection all lie in the same plane. This is a plane, a normal plane. Okay, that is one rule. The second rule is the angle made by the incident ray with respect to normal and the angle made by the reflected ray with the normal. This is angle of incidence. This is angle of reflection. Both angle of incidence will always be equal to angle of reflection. This is the second law that we know with respect to this reflection of light. So every time the reflection of light follows these set of rules, because of which we can identify certain component with respect to the reflection. Now next we are moving on to types of mirrors. When it is coming out to be a reflection is the concept of a mirror. And mirror, how many types of mirror we study under our physics, that is spherical mirrors. There are two types of mirrors. One is known as concave mirror and another one is known as convex mirror. Concave mirrors are the mirrors whose reflection is towards the center. All the reflection process, whatever takes place, is towards the center. If this is a focal length, this is how it goes. Where exactly convex mirror is the one which has got the reflection behind, that is in this manner. This is the reflection. So the curved surface, the curved outer exterior region is the one where exactly the reflection takes place. That's all about your spherical mirrors. And next we are going on to the components of the spherical mirror. So for a spherical mirror, for us to understand if this is a spherical mirror, the center line which runs or cuts the spherical mirror at the middle is known as principal axis. This is the axis which is cutting the mirror into half. So principal axis is done. The pole or the vertex, the point of intersection over here is called as the pole or the vertex. In case of lens, it becomes optic center. And next we have center of curvature, which is actually the radius, which acts as a radius, correct center or the middle part of the spherical mirror. And then we have a radius of curvature, that is the distance between the pole as well as the center of curvature. Next we have principal focus, that is, it is the mid part of the pole as well as center of curvature, known as principal focus. Focal length is the distance between principal focus and the pole, which is termed in terms of f. And next we have a focal plane. So this will be the focal plane. So that's all about your components of the spherical mirror, that you have to understand how exactly the mirror components are read out. So that mirror image formation will be much easier. And remember, whenever the image has to be formed, any 2 points of intersection, that is any two set of rules has to be considered, so that there will be a point of intersection between two rays, and that will be the formation of the image due to an object. So next you have relation between focal length and the radius of the curvature, for which we will have to consider a mirror. So you have a set of mirror over here. Let us consider a concave mirror to which a principal focus is falling, and we have a pole here. We have a center of curvature as well as we have a focal length here. So any ray which is passing and hits here, it reflects and passes through the focal length. Okay, so you can just with the help of a dotted lines, you can just connect your center of curvature as well as construct a perpendicular to the pole which is very much equal to pole, which is named as D, and let us name this as, it's a ray which comes, and let us name it as M. So you have C, M, D as well as F. Consider this angle to be 2 times that of the theta, and this is the angle theta. So when we have this as the construction set in order to calculate relation between focal length as well as radius of curvature. Focal length is termed in terms of F and radius of curvature R. We have to check the relation between F as well as R. So we have 2 set of triangle. One is with respect to dotted lines, which is called as theta, M. This point is known as C. This point is known as M, as well as this point is known as D. As well as we have another triangle. So this is another set of a triangle which has 2 theta. It is M here, it is D here as well as F here. So now considering a tan function, tan theta is equal to opposite by adjacent. Opposite is your DM, adjacent is your CD. So similarly you have tan theta is equal to opposite is MD or DM, and this is FD. We have 2 set of equations, whereas this theta is nothing but tan 2 times theta is equal to MD by FD. Let us consider this as equation 1 as well as this is equation 2. Now suppose if the angle is very much smaller, then the tan theta becomes equal to approximately equal to theta, and it turns out to be theta is equal to dm by cd, this equation, and here tan 2 theta becomes approximately equal to 2 theta. So 2 theta is equal to md by ft. So this is one equation. Let us consider this as 3 as well as this as 4. 1, 2, 3, 4 equations we know. So now equate this 4 as well as 3. So on continuing this, we have dividing 2 theta divided by theta is equal to, it is md by ft, and you have cd by dm or md. Cancel. So you have 2 theta divided by theta is equal to cd by ft. So on calculating this, what is your cd? Cd is nothing but radius of curvature, ft is nothing but focal length. So 2 theta divided by theta is equal to r divided by fd is nothing but your f. So theta cancels with theta. So we have r is equal to 2 times the f. So this is the final set of equation. Radius of curvature is always double times that of the focal length. So that relation we study here. So we have r and f. So what is the relationship between f and r? It is r is equal to 2 times that of the f is the relation. One of the most important concept in order to tackle with the numericals or the applicative type of questions. So next we have refraction. So for here we are done with respect to reflection. Now we are getting on to refraction. So in case of refraction, you can see here, whenever a pen or a pencil or any of the thing is just dipped into a water as such, what happens? There is a deviation which takes place when a ray of light passes from one medium to another medium. That deviation you can observe over here. This is the deviation concept, what has been taken at certain angle. Okay. Again over here also we have at a certain angle the deviation has been taken place. So that deviation is known as nothing but refraction. The bending up of a ray of light is known as a refraction. But when does it bend? When it travels from a higher medium to a lower medium. That may be a denser medium to a rarer or rarer to denser, either of the two. So we have certain set of rules with respect to reflection, and also that is first law of reflection is same as that of the first law of refraction. All lie on the same plane. Angle of incidence, normal, as well as the refracted ray, all three lie on the same plane itself is what? the first law says. And the second law turns out to be the Snell's law, that is ratio of sine of angle of incidence to sine of angle of refraction is known as the Snell's law, which we will come up with further concepts. Out of this refraction concept itself, there is another component which arises, that is called as a total internal reflection. Due to set of refraction, whatever takes place, there is a reflection what is happening due to refraction. Those set of refraction are nothing but total refractions, whatever is taking place. But what happens when a ray of light travels from a denser to rarer medium and the angle is greater than that of a critical angle? So what is a critical angle? If suppose you get an angle incident from a denser medium for which we get a refracted angle greater than 90 degrees is called as a critical angle. So for a total internal reflection, that is again it reflects back due to the help of refraction, and that happens only if the incident ray is greater than that of a critical angle. So one of the example is like whenever during a heavy summer, whenever you travel in a highway, you can see this watery formation, but that is a mirage what is forming. And here also in oasis, that is in your desert, you can find out the presence of a water, just the assumption or an imaginary concept of the presence of water, that is called as a mirage. That is due to the help of a total internal reflection. So now just let us see how exactly the total internal reflection is taking place. So this is a plane on which the total internal reflection takes place. This is a denser medium and you have a rarer medium. So whenever a ray of light is incident, always according to the rules, the ray of light should be incident from the denser towards the rarer. So you just draw a normal to this. If the angle of incidence is lesser than that of a critical angle, then you get a deviation like this. So this is the angle of refraction. Next, whenever the ray of light is incident in such a way that it gets a refracted angle with respect to 90 degree, then you can say that angle of incidence is equal to critical angle if the refracted ray is at 90 degree. So total internal reflection takes place only if the angle of incidence is greater than that of a critical angle. So for an angle which is greater than that of a critical angle, if this is normal, then it gets reflected back. So this arrow mark gives you the exact term. Okay, so for which angle of incidence is greater than that of a critical angle. So this holds good, that is the third one holds good with respect to your total internal reflection. Next we have what is meant by lens. It is an optical medium which is bounded by two sides, okay, which is also called as a spherical lens. It's a lens. A lens is an optical medium which has either two spherical surfaces or one spherical surfaces, or one plane surface and one spherical surface. That is how exactly it is. So there are four types: biconcave, biconvex, plano-concave and plano-convex lens. These are the general concepts what you have to know with respect to the lens. So now let us just derive a formula with respect to a lens maker's formula, for which we have a lens and we have a principal axis, and the center of this is known as optic center. Okay, so we have A, B, C, D is a lens what we have, and there is a set of image formation which happens over here. So suppose if there is an image over here, the image which comes and falls over here, and normal which is drawn to the surface. Again there is a normal which is drawn to the surface, and then you have an image formation here, we call it as I. So the distance from the object to optic center is known as U, and from the optic center to image distance is known as V. So this is a set of formation what we have with respect to lens. So now what are we supposed to do? We have to break this into half. How do you do that? You have one set of equation. Let us just check case 1. One mirror formation, image formation, that is a lens form. So we have optic center over here and the object is over here, O. Let us call this as OP. And from here there is an image which is falling, normal which is drawn to it, and from this image itself you have a deviation, that is whenever rarer to denser. This is a rarer medium, this is a denser medium, so we can call this as N1, this is N2 and this is N1 back again. So rarer is nothing but N1, denser is nothing but N2. So from N1 to N2 when the ray falls, no deviation because single spherical surface we are considering. Only the deviation, one single deviation happens. It's not two deviation which happens here. That is from rarer to denser when it falls, the deviation is towards the normal. So it comes out to be like this. So this is your, consider this is your I dash because we have already have I here. So from here to here the object distance turns out to be U, and from here to here the image distance turns out to be V dash. Okay, so that's all about what we know. So now for this, if you have to consider, we have using the set of, that is a equation for a spherical lens, that is we have N2 by V minus N1 by U is equal to N2 minus N1 divided by R. This is the equation of the spherical lens what we have, where n, all the n's are the refractive index with respect to first medium, second medium. V and U are the object distance and the image distance, and you have R as the radius of curvature. So now let us just consider with respect to that, N2 divided by, we have V, that is nothing but V dash, minus N1, rarer medium, you have U. So U is equal to N2 minus N1 divided by, we have a radius of curvature, let us write it as R itself. So for us to easily convert it and calculate it, we can consider this V dash as V1 also, or else we can consider even as V1. So let me continue with respect to V1 now. So we have N2 divided by V1 minus N1 divided by U is equal to N2 minus N1 divided by R. So let me consider this set of equation as equation 1. Similarly, first half is done. Let us consider the second half of the set. So we have second half of the equation, that is we have a ray which passes like this, a normal which is drawn. So from a normal you are just moving away. So this is I. So you from optic center to I you have image distance V. So now object distance acts as the previous image distance, that is V1, and image distance acts as V, whatever we have got now. So according to the set of equations what we have with respect to N2 divided by V minus N1 divided by U is equal to N2 minus N1 divided by R. Since we had considered the previous one as R, since it is V1, you can even consider this as R1. Similarly, you can change this as R2. So this can be considered as, since this is N2 and N1, image distance is with respect to N1 by V minus N2 by, we have V1 is equal to N2 minus N1 divided by R2. But this time on equating that the other way, we will have a negative of R2. So we get it to this form in order to equate with the previous question, that is N2 minus N1 divided by R1. So this is another set of equation. We can call this as equation 2. On equating 1 and 2, we will have N2 by V1 minus N1 by U plus N1 by V minus N2 by V1 is equal to N2 minus N1 divided by R1 minus N2 minus N1 divided by R2. So when we just equate this, we will end up with N2 by V1 minus N1 by U plus N1 by V minus N2 by V1. So here this is similar to that of this with the negative sign. So this and this gets cancelled. So we have N1 common out with 1 by V minus 1 by U is equal to, we have N2 minus N1 as common out with 1 by R1 minus 1 by R2. So we can just have this like, get your N1 with the right hand side component, 1 by V minus 1 by U is equal to N2 by N1 minus 1, because N1 by N1 cancels, 1 by R1 minus 1 by R2. So next we have 1 by V minus 1 by U is nothing but 1 by F with respect to the formula we have and length formula. And next we have N2 by N1 with respect to Snell's law. It turns out to be N2 1 minus 1 of 1 by R1 minus 1 by R2. So this is the final equation which represents the lens maker's formula. So it's very easy whenever you divide a lens into, break it into two halves and equate the formula. And next we have a refractive index in terms of angle of prism and angle of minimum deviation. So for which you have to consider angle of prism is known as A, angle of minimum deviation is known as D. So we have to equate this as well as this with the help of series set of equations. So for which we have a prism. This is a prism whose angle of prism is given in this manner. So any ray of light which passes, that is the incident ray, will have a normal drawn to it. So we have a line like this, again normal drawn to it, away from it. Okay, this is how exactly the things goes. This is angle of incidence, this is angle of refraction. So whenever you join these dotted lines, you have A, B, C, and you have P, this point as Q, this point as R, this point as S. So the extension of these two things give you T, and the extension of this gives you Z, which gives you the deviation. Okay, so this exactly how it goes. So now we have, let us just separate it later. So now first case you have your Q and R extended in this manner. So you have your T here, you have your S, you have your angle R, you have your angle of incidence I. So here it's Q, so here it's R. You got to know the things now. So this is the refracted angle. So the complete thing is angle of incidence. So with respect to this, we have from I1, we are subtracting R1. That is, sum of interior angle is equal to exterior angle concept we have to find out. So first of all, we will just equate the set of concepts of this. So we have I1 minus R1 for this angle, that is this angle. Okay. Next, at this condition, we will have I2 minus R2. So these are the conditions. So suppose if it goes with the case according to the formula as such or according to the laws. So the first law states how to be. So if you go with respect to the laws, we have I1 minus R1 to this angle, I2 minus R2 for this angle. So the exterior angle is said to be D. So exterior angle is equal to sum of two interior angles, that is I1 minus R1, and we have I2 minus R2. This is a set of equations. So which D is equal to I1 plus I2 minus R1 plus R2. So this equation we can call it as equation 1. So this is the deviation angle, what you'll have to know. The second set of thing is, concept is with respect to the angles. So it is 180 degree triangle. You'll have to consider P, Q, R as well as S. So you have a triangle QR, let me name this as N. So you have N over here. Triangle QRN, we have angle N plus angle R1 plus angle R2 is equal to 180 degree. So let me consider this as equation 2. And now we have the third set of equation, that is with respect to quadrilateral. You have Q, A, R as well as N. That turns out to be angle Q plus angle A plus angle R plus angle N is equal to 360 degree. Angle Q, here whatever angle is there, that will be at 90 degrees. Angle Q as well as angle R is at 90 degrees. So you have 90 degree plus angle A plus angle R is 90 plus angle N is equal to 360 degree. So 90 is 180, 180 minus 360 again 180 you have. So if you just have this, angle A plus angle N is equal to, you have 180 degrees. So we can equate equation 2 as well as equation 3 with each other. So we will end up with angle A plus angle N is equal to angle N plus R1, angle R1 plus angle R2. N and N gets cancelled. So A is equal to R1 plus R2. So this is the angle of prism. Call it as equation 4. So we got to know what is angle of prism. Now with the help of this, we will have to find out angle of deviation. So we have got this one. Now we have to check this and finally equate both together. On substituting, so we have equation D here, that is equation 1 here. Substitute this value in terms of equation 1. So we have D is equal to I1 plus I2 minus R1 plus R2 was our equation. But R1 plus R2 is angle A. So we have D is equal to I1 plus I2 minus A. This turns out to be the deviation. Let me call this as equation 5. But suppose if you just have to check the angle of prism and angle of minimum deviation in terms of refractive index concept, then suppose if your I1 is equal to I2, all are equal to I, and R1 is equal to R2, both are equal to R, then using this condition we can write D is equal to I plus I is 2I minus A, and I becomes equal to D plus A divided by 2. Okay, or A plus D divided by 2. Let me consider this as equation star. Okay, similarly, if we just consider with respect to R, we have A is equal to R1 plus R2. A is equal to 2 times that of R, or R is equal to A by 2. So we have this also as equation star. These two are set of equations what we have to know. So having these two, refractive index with respect to refraction is sine of angle of incidence is divided by sine of angle of refraction, that is known as Snell's law, which is also called as the refractive index. If we just apply to that, n is equal to sine of angle of incidence is A plus D by 2 divided by sine of angle of refraction is A by 2. So this is the final expression of the refractive index in terms of angle of prism and minimum deviation. So let us all meet in our next upcoming classes with a new chapter. Until then, have a good day. Thank you.